In this video, we are going to find some probabilities by using combination. In the question, it's given that there are 13 boys and 15 girls in a class that is a total of 28 students. 6 students are to be randomly selected to form a volunteer group. And we have to find the probabilities that the group consists of different numbers of boys and girls. Before we find the answer of each part, let's have a look at the various ways of selection first. 6 students are to be selected, so the possible ways are like this. Then, to find the required probability of each part of the question, we only need to find the number of possible ways to select the boys and girls as specified, then divide it by the number of possible ways of selection with no restriction, which, in fact, would be the same as the sum of all these possible ways. Since the selection is regardless of the order, we are going to find the combinations. So what's the number of possible ways of selections with no restrictions? There are a total of 28 students and we are selecting 6 at a time, so it's 28C6. Now we are all set. Let's look at each part of the question. Part A. The probability that a group consists of 2 boys and 4 girls. So we are looking at this case. 13 boys taken 2 at a time and 15 girls taken 4 at a time. The number of ways of selection is 13C2 times 15C4 divided by 28C6. Using calculator, the answer is 13/46. Part B. The probability that the group consists of at least 2 boys and at least 3 girls. To have at least 2 boys, that means we can't have no boys and only 1 boy in the selection. Then to have at least 3 girls, we can't have no girls, only 1 girl and only 2 girls. That means we are looking at these 2 cases, 3 boys and 3 girls, and 2 boys and 4 girls. We can use the addition law of probability to find the answer. We've already found the probability of having 2 boys and 4 girls in part A, which is 13/46. For the case of 3 boys and 3 girls, the method to be used is exactly the same as in part A. That is 13C3 times 15C3 over 28C6. Using a calculator, the answer is 130/207. Part C. The probability that the group consists of at most 5 girls. To have at most 5 girls, that means we can have no girls, 1 girl, 2 girls, 3 girls, 4 girls, and 5 girls, but not 6 girls. In other words, the event 6 girls are selected and at most 5 girls are selected are actually complementary events. So we can calculate the probability that the group consists of at most 5 girls by subtracting the probability that the group consists of 6 girls from 1. The probability that the group consists of 6 girls is 15C6 over 28C6. Subtracting it from 1, the answer is 817/828. That's it.